All right. So yes, so like I mentioned, from like that lot, before our little break, um, we're gonna go over we're gonna use the Kaggle competition to kind of like frame a little bit of doing a linear regression walkthrough. And so my hope is that like I'm gonna show you a little bit like from this competition like what we can do, but also that should hopefully translate well to the phase 2 project in doing linear regression. So I hope to kind of like do something a little more realistic, and also you get to see me also fumble over some code and like more realistic, which I think can also be really reassuring, which is like just showing like, oh, here's a completed notebook, and it's completely done already, where I've taken time to actually like make sure it's fine. So let's see. So the competition, first of all, we got some 3 submissions, which is awesome. For the record, like there's a private leaderboard, which I'm not going to show right now, but I will tell you is that this isn't the full story. There's definitely some other stuff that can happen. We still got 3 more days to go. So just know that there's lots of potential here. So anyway, I think it's good time.
Don't trust my leadership in this thing. I just
Don't trust yourself.
I didn't I didn't do anything. I just submitted and somehow.
Yeah, that's all it takes. So that's what's kind of cool is that if we do this right, you guys should actually be able to just copy this code notebook I'm going to have and actually submit it onto this competition. So you can use that. You can literally copy it, submit it, and then modify however you want. So it could be a good starting off point. So yeah, so hopefully everyone who's here, who's watching this, you can take this code notebook and at least have one submission there, and then you can modify it however you want. All right, so let me go create a new notebook here. Yeah, you can hear my dog barking right there. All right. So again, just kind of reviewing like what I just did there. I went to the code section here for the competition, and you guys all hopefully know how to get to here now. But you can click New Notebook, and that will actually create a new notebook with the data for this competition, which makes it kind of convenient for us to practice with. I also could like do something with Jupyter Notebook and upload it too, so you could also do that, and then do however you want. I'm just going directly on Kaggle here just because it's just a little bit easier for me to get all the data in here. But it also, yeah, you can download this if you want. So like I said, Kaggle automatically makes this stuff here. I'm going to rename my notebook here. I'll just call it like linear regression walkthrough. Okay. So I'm going to go ahead and run this guy here. Note this is already connected, and you can get all my data in here. Remember, we have the trained data, which is basically this stuff with the features in my cup so it's not so wobbly. It's all the features and the target, and the test data is all the features, but no target. So this is what we basically submit on top of, right? So just kind of remember that. All right, so we have our data here. The first thing we should probably do is actually load in our training data. So let me just do, I'll call it train df. I'll call it df train. So df train, pd.read csv, and then if I do tab here, it's a little bit easier for me to input. Okay, and then I'm gonna do train csv. Okay, so I'm gonna actually make this markdown here. So I'm trying to like emulate a little bit like what you would do for the project. So you would obviously have your business case here. So I'll just put a little bit markdown, project overview. So things like, oops, your business case. Oops. And then, other details like that. So like data description. Those are things that you would put in there. And then I'll actually put in here, like, I'll just move this section up. So this is where like I'd have all my imports. So I'm gonna keep that up there just so it's information. Oops. Okay, oh, I don't think. So let me go ahead and import some extra stuff too, because I like my imports. So let me go ahead and import, we got Seaborn as SNS. So for the record, Kaggle has some packages already installed. You can install it with pip install, but also there might be slightly different versions from what you have. So just kind of be aware of that. But I think it should be fine over here. So import Seaborn, and then I'm going to import sklearn. We'll probably have some more imports after that. And then one thing I'm going to do too is import matplotlib. pyplot as plt, and then our good old matplotlib inline, which makes things just a little bit easier for us to see when we plot it. Okay, so cool. Got my imports. Cool. So much work already done. All right, so we got our data loaded in here. So I'll just say, for example, let's I'll put like, let's say data load. And this is where like what I personally do is what I'll do is I'll make new sections before I actually like write anything in them, just to kind of help me like remember like where things are and stuff like that. So that's just something I do. Like you don't have to do it this way, but I think it helps. So data load, let's say data cleaning, and then I'll call this feature engineering. And I'm doing this because it's the data life cycle, but like you could have other sections or these sections overlap with each other or whatever makes the most sense when you're actually putting this material together. I'm going to say model training. And then after that, I'll have, oops, can't remember what I'm doing, model validation or evaluation. So this basically is for me to say, okay, after I train my model, how well is it actually performing? Okay, so for the record, like your structure overall probably is going to look something like you have your data loaded because there's probably just the data loaded once. You don't have new data. Data cleaning, you're going to clean it once. There's nothing really like to change between different models for the most part. Feature engineering, this is where like between feature engineering, model training, and evaluation, you might do that like 4 times or whatever it takes. It might only be twice or 3 times. The reason why is like you might have a model perform and you're like, oh, that does so well. Let me go ahead and do new features, do the training and evaluation afterwards. So you can kind of imagine this might end up being like a section per model, or these 3 sections per model. You can do it other ways too. You could potentially just do all feature engineering, then doing all your model training, then do all your model evaluation. Just whatever makes the most sense. But I think what I'm going to do is I'm going to focus on making these sections new for each time I make a new model. So I'm going to put like model. So model, I don't know, -a. I'm just calling it something. Okay. And then one thing we would typically have is something like, conclusions, summary. All right. So I like structuring, again, like I like structuring my notebook before I actually do anything, because it kind of gives my head and say, okay, what do I expect? What do I expect to do? Okay. So now I can load the data. So let's go ahead and load data. I'll just say, like we'll take in the training data and split it for validation. Okay, so I'm going to do this guy, run this. I got my data. Let's go ahead and see df.head. So this is where, df train.head. And this is where like I don't like making new cells. Display train, df.head, and then display df train.info. Okay, and then I don't know about you all, like I kind of like dark mode, just a little bit easier on my eyes. So I'll use the dark theme here. Okay, so nothing major. Okay, so I'm like looking at this data, it's like, okay, cool, let me check out this data. We already know there's 82 columns. So in this case, this should be 81 features plus the sales right here. And you can already see, I'm not going to use all 81 features, right? So I'm going to kind of hone it down a little bit. Maybe I'll look at what we're going to look at for the project and focus on those ones. But you can already see like things like PID. I know order is actually going to be the thing that we use to identify, what things what. So I'll keep that in there essentially as an index number. But then I also have a PID. I don't know if that's really going to be useful for me. I don't know what this is. I could probably look at the data and see, or the data dictionary, and say, hey, what do these things mean? But I'm just going to take some guesses. Subclass, don't really know what that is. Zoning, looks like categorical here. Loss frontage, we already see that there's some, or lot frontage, so probably something about lot. Looks like we already have some missing values. So we're getting some information. You can see here it is about 2,000 entries. So this is relatively nothing too big. Like this is pretty small, actually, all things considered, which linear regression does pretty well with small data because you can kind of define what things you want for Some other machine learning algorithms typically need like larger data sets and stuff like that to do well. So something to know about. You can see here, like, okay, it looks like most data is filled in, and there's a few of them, like for example, Ali, it's 146 non-null. I'm not going to keep Ali. Like Ali is just, it's gone. So, you know, for example, I'm going to say, okay, like things to, I'm going to just take some notes here. It's like, okay, like things to remove, and I'll say something like, I'll say columns to remove, or features to remove, and say Ali. So Ali, no, almost no data. So that's obviously one that I'm going to remove. And you can kind of see a little bit like, oh, other things I might remove too. It's like, oh, PID. I'm going to say, oh, okay, PID.
Victor,
Yeah.
isn't this information layer confusing that you have a 2197 non-null and again 146 non-null? Like, shouldn't it say null only?
You could look at that. But yeah, it just depends on what you're used to. I'm saying that there's only 146 that are non-null, meaning that there's only 146 that don't have missing values. Does that make sense?
146 that doesn't have a missing value. Okay. Okay.
Okay. Yeah. You like honestly, it's just probably because I've seen df.info so many times that I kind of look at this and I kind of already know like, oh, this is just how much data is available versus how much missing data. But you could do it if you wanted to. You could look at just the null data and say what things are missing. But yeah. Okay. So yeah, kind of continue on then. I'm just looking like, okay, like obviously missing data is here. If I kept going through, there's obviously 80 features on here, so I don't know if I want to keep everything, right? I'm not going to go through all this stuff, but you can already see like, oh, there's a lot of missing data in here that's just not going to be useful. Other things I might note, for example, is object is I say, oh, like for example, looks like there's a few categories, you know, so I might put something like this is an example, basement quality. So I might something like, you know, like, oh, like, you know, basement quality category might not be useful. So maybe, for example, I'm saying cleaning stuff. So things to clean. And again, I could come back to this later on and like reformat this into something a little bit easier to read for other people. But the important part is I'm looking at this and documenting what I see. That way, when I come back to it like the next day, I know what things I've already seen and what I'm going to do with them. Okay, does that make sense to people? Cool. I'm not going to go into full detail there, so I'm going to skip that over. It's like, okay, so data cleaning. So in this case, I'm going to create some code. So say, you know, let's focus, say, since there are so many columns, let's specify which ones we think are the most important. Let's specify which ones we think are the most important and keep it to a relatively small number of features. Okay. Boom. All right. So this is kind of giving it like why I'm going to use specifically. I'm going to state which ones I care about. And so let's go ahead and list those out. So like, you know, like let's list those columns to see which ones make sense. So this is probably technically part of like maybe my exploration, but that's kind of like what this is right here is my exploration phase. But you kind of go back and forth, so it doesn't really matter too much. So let's go ahead and write some code here. Okay, oh, that was code. All right, so let's go. I don't need to put a column there. So let's say df train.columns. Right, so you can see all these columns here. And what I'm going to do is I'm going to compare it. So let's want to make sense. We'll use the other projects columns as a guide. So what I'm saying here is that there's some columns that were from this guy right here. So we see that this is from the project that you guys are actually going to do. I'm just going to keep things that are close to this set of columns. Does that make sense? So say from other project And this is where I go multi-edit. So I'm just holding control click just for the record. So there. Okay. So I can see a little bit like, oh, these are the columns from the project. I want to keep those ones. These are the ones that I actually do see in here. So let's see what the ones that we want. So I'm going to create a little code here and say columns to keep. Okay. So I'm going to go a little bit up and down here. So let's say our date. So do we have a date on here that's similar to date? You don't see anything? Year sold? Year sold. Okay, that's like a date. So let's do columns to keep. We're going to have year dot sold. Okay. And what else we got? So we got date in here. So I'll put a little column here and say like date. Okay. What else we got? So we want view. Has it been viewed before? Just looking at this very briefly, does that look like something that we have in here? I'm going to say I look through and say, oh, no, I don't find that in here. So I'm going to ignore it. So let's see. Okay, columns we're going to keep. We're going to ignore view. Let's see, square footage above. So let's see something like square footage. And you feel free to chime in too here. So lot area, that seem right? Seems close. I could probably look this up and double check that that's actually what lot area means, but I'm like, okay, like lot area similar to square footage above. Okay. So note that I'm kind of using some assumptions here. That square footage above is kind of like how big the lot is, which might not actually be true, right? I'm pretty sure if we wanted to, we could probably find out specifically how much square footage. But if I look more closely, I don't know if anyone sees that in here, but I'm just gonna move on to that. Okay, and then what else we got? Let's skip over to year renovated. I guess it's like year renovated. Is it been renovated? I don't really see that in here, so I'm going to skip that over. And let's do zip. I'm going to skip zip code long lat just because that might take a lot of effort for us to like do some feature engineering. But we could potentially do something with that like zip code longitude latitude. It probably by itself isn't going to be useful. It might be more useful to kind of build up a new feature from that. So yeah, so that's kind of all the stuff that's like at least I see immediately that's related to what we have. Does anyone else see anything different that maybe we should include? That's related to at least the first one. No? I hear anyone's chiming in. So, all right. So let's say I'm gonna try to keep now some like other features that could be useful. So let's see here. Let's check a little bit of our info. So you see me kind of scrolling up and down here. I'm not documenting this, but that's okay. So I kind of like the list of here because it's a little bit easier for us to read things through. So let's see here, mass and for I want to look for things that I don't have to transform too much is what I'm looking at. So you see plot here, we have int64. So let's do frontage too, because maybe the front part of the lot matters. Let's do lot frontage. And we can see there's actually some missing data in here. So that'll be fun to actually try to do some basic cleaning. So columns keep, lot frontage. Okay, what else we got here? Basement. I'm gonna ignore basement. I'm in California. No one has a basement here, so I don't know what to do with that information. All right, low quality GRV living area. I don't know what that means, but it sounds important, so I'm gonna keep that with me. Let's say full bath and half bath in 64. That's probably how many full baths and half baths they have. So let's go ahead and do this guy here. Oops. So I think that's like, I don't know what the GR stands for. Maybe it's grand or something. Again, this is where you'd actually check out like what is in there.
I interpret it as gross living area.
Oh, that makes sense.
Yeah, like, I think that's total square feet.
Okay, so that's actually probably closer to like what we actually mean by square footage above versus lot area. So I think that sounds pretty important. And then I have full bath and I want half bath. Okay. And I think that's a good, like for now, like we're just going to focus on those 5 areas. These seem pretty important. Like the first few things I probably would ask about the house, right? There's a bunch of other details that could add some stuff. But I think this would be like the most bang for a buck. Okay. I'm Andres says neighborhood. What's neighborhood? Is it just neighborhood in here?
Yeah, I agree. At the neighborhood, I ran a average sales price and it's quite different. There's about 30 values. So that's a good category, I think.
Okay. Yeah, and this looks like an object, so looks like maybe it's like some like you said, like a category. So I was kind of avoiding some of those, but maybe we have some time to do that. Okay. So oops, not marked down. So I'm gonna write some code here. And so these are the columns to keep, and then I'm actually going to go ahead and df train. So this is where I'm actually gonna write a little function here. So I'm gonna say, define filter columns. Okay, and it's gonna be my data frame is in here, and then I'm just gonna define it in here. And then what I'm gonna do is say, okay, like let's do df. So I guess I'm kind of jumping ahead of it myself, is that let's see if this actually works first. If we can, like sometimes it's useful just to see, does my code work? So let's go ahead and columns to keep and df, oops, I can just do columns to keep. And let's do dot head. Oh, helps if I actually spell it right. Okay, so good, looks good. All right, so in that case, what I'm gonna do here with my function here, and I document it, right? I can put in a doc string. It's like return data frame with only certain columns. Okay, so df is going to be, I'm going to return df, and then I'm just going to filter out those specific columns keep. Okay, so hopefully this makes sense now, because then I can come back here later on, right? And I can say, oh, I want to add these columns in there. I was like, oh, I shouldn't have kept those columns in there, and I can change this function out really quickly, right? So I can do df train, something called df filtered equals df train. These are filter columns. And then if it df filtered, we should get the same thing as before. Boom. Okay, makes sense. So I'm gonna assume that was all cleaning. I like all like the filtering stuff. Like you obviously would have a lot more involved in here, but this is the idea, like how you would do this stuff. Okay, makes sense to everyone? Yeah. Okay, cool. So I'm gonna make a little subsection here. So, so one thing I want to check out is actually see, let's see, df.info, oops, df filtered .info. What do I do with this? And you can see like how much this could actually be a lot of effort. In this case, there's only like one missing value. It looks like neighborhood as object. So let's explore that a little bit. So I'm going to say, missing values, oops, values on, what was it called? Lot frontage. We'll need to address that. Fill. Okay, and then we can also see objects. So say neighborhood is an object category. Okay, so let's actually check that out. So let's see, df filtered dot neighborhood. There we go. It's a little slow. All right, and then dot unique. Oops. Okay, so okay, good. There's not that many categories in here. So you say, okay, there's some categories in here. So this is where I actually go into and say, okay, like let me go ahead and like make these into like one hot encoding, right? So I don't know if we actually showed this before, but what we could do is use sklearn's one hot encoding. So one hot encoder. So you can see a little bit how this works. So I'm going to copy this guy and I'm going to add this into my imports. So let me just go ahead and put in here. So import from sklearn, import one hot encoder. Okay. So now I should be able to use that, right? So So let's go ahead. One hot encode neighborhood. Oops. Okay, so let's just double check this. So one hot encoding. So let's say we don't really know how one hot encoder works. We could look at the documentation. How does it work? And what's nice with sklearn? Usually they have an example. Sure enough, there is. So we can see here, we create this encoder, handle unknown equals ignore. Okay, so that means basically if there's new data that it hasn't seen before, we should actually like treat it as like just don't worry about that. So that's what that ignore is, because we might have it expressed for training and tests. So like that reminds me like, oh, I got to do some training and tests, right? So I'm going to go put this on pause for a second. So I want to come back to this, but I say, oh, I should actually do some splits. So let's go ahead and before we actually do some anymore, I'll put a little mark down here. It's like, before going further, we should split our data. We should keep a holdout set. Okay, so this is what I kind of talked about, like, oh, we should actually have something that we could split this. So this is from sklearn dot, oh man, model selection, I believe. Import train test split. Okay, so that's what we'll use right here. I'm going to just run that underneath here. And then let's do df train. So one thing we have to do is actually have our, let's say our target is equal to df train. And then I believe it's the last one. So I'm just going to go iloc all the rows. I guess I should name it specifically. I could do that. df train, what was the sales price, right? Sales price. Okay, so that's the actual feature there. That's my that's my target. And then features is going to be df. I guess I got it filtered. Let's do filtered just to make sure we keep everything nice and clean. And this is going to be, well, this is where I can specify which things to keep. I guess this would have to be, sorry, you see, this is where I'm kind of going back and forth a little bit, right? You see, like, oh, this won't work because I didn't keep that on here. So I should actually just do df train, but I'm kind of hesitant in doing that. I should really keep this as one of the targets underneath here. Okay, because I could use train. Hopefully that makes sense. Is that like why I want to specify in here? Make sure you got that. Okay, good. And then let's just do sales price. And then let's just do, I'm going to use .iloc because I'm lazy. So all the rows, last column. And just to make sure I did that right, because sometimes I write that wrong. Doesn't hurt. Oh, see? That wasn't right. It should be, oh, because it should be everything up to the -1. There we go. So then we got all these parts in here. Cool. So that looks good. I'm going to move this guy up here. Okay. So, and I might actually go back to this later on and say, oh, I should actually move that train split, further up, or all that stuff. So let me go back to here. So I get my features target. And then what I'm going to do is actually train split. So let's do train split. And that's going to be my, let's see here, just to make sure I got this right. Sorry, I'm not on my normal, I can't use my shortcuts. So let's go help, train test split. Gives me some information, and it should be, let's see here, the arrays, which I believe should be x train, yeah, x, y, and the size. Okay. So I'm just checking out the documentation. I could have looked it up too. So our xy is going to be features, target, okay, and then test size. This is relatively small. I'm going to actually use only like 0.1, right? So that's the reason why here. And then I'm going to just call this x train. This is where I don't like typing it out, so I'll just copy it from here. So Everyone follow me what I'm doing so far? Cool. All right. So got my split. Cool. All right. Now we can say create neighborhood one hot encode. Okay. So cool. So now we can do that. All right. We got the unique in there. Looks good. This is where I should technically, if I really wanted to, well, just to show a little bit, if I do X train now, I believe that's a NumPy array. No, good. Oh, sklearn is so smart. I don't have to worry about getting out into a data frame. So I can actually just use xtrain.neighborhood.unique, and then I'm going to say encoder. Like I was talking about, I can just use what someone's already done before. So you can see the X, I can do the fit, and then do the transform itself. So, okay, so I got my encoder. I'll call it neighborhood encoder too, because remember we're doing specifically for this one. So I want to kind of make it, my mouse is dying, I think. There you go. Encoder, oops, neighborhood. I'm going to keep it lowercase just to keep things nice. And I'm going to fit it on this case on specifically xtrain.neighborhood. Okay. Does it make sense to people so far? Oh, maybe it didn't make sense. Oh, this might be why. This is probably the reason why I didn't want to use data stuff. So I think I have to go. I have to do a dot reshape. That's probably what's going on here. Let's see here. Dot reshape -1 to 1. Okay, this looks good. So you can see a little bit I'm experimenting and then writing it in here. So hopefully that makes sense for people. And then what I might do is explicitly call it in here and say reshape after getting the NumPy array. Okay, so now it's fit. Okay, so the reason why I had to do that reshape is because remember it's expecting, you know, each row, right, in one column. So I had to reshape it because there's only one of them in there. So, okay, now I can actually transform it and say, let's call xtrain. I'm just going to recall it neighborhood. So, or I guess xtrain dot append. So I think I can just do append here. So one thing, the problem I'm doing is like I'm adding multiple rows here. So if I use that in here, let's actually check the documentation. I can do the transform to array. Let's see what this looks like. So that is what I want here. I want to make sure that I get this first. See, there's a bunch of things I should actually be doing too. I should be doing drop first here. So tell you what, just to make sure we have enough time, because I don't want to keep handling just this one feature. We're just going to say like, we're going to reshape it. We're going to pretend, oops, let's see, it should be, no, okay, see, I got to pay attention more, closer attention. So I'm just going to put a little here, it's like, you know what, put a mark down here. I'll say to do fit, and this is where I have, I actually have a little keyboard shortcut that I normally would put here, but to do transform neighborhood one hot encode. Okay, so what I'm going to do here is I'm going to cheat and just say, all right, X neighborhood. I know you guys have said it was important, but I'm not going to take my time doing it right now. Is I'm going to say xtrain neighborhood equal to 1. There you go, one hot encoded it. So obviously that's not going to be super effective, like, but I'm just kind of moving on to the next part. Okay, so if I look now, if I look at xtrain now, dot head, we should see that neighborhood just a whole bunch of ones. Okay, that's the cheating way. You don't want to do that, but I'm just going to move on so that way I can do stuff. Okay. I do have a meeting in like 10 minutes. I want to make sure it gets through some stuff. So I got my features in here. I say some feature engineering. I guess technically I could move this over into feature engineering, all that good stuff. Let's do some model training, right? So let's go ahead and just say, okay, I have some missing data. Where was it? In lot frontage, right? Was it lot frontage? No one remembers. It is? Okay, see some nods. Okay, good. So let's just do real quick clean fill missing values. So we have df train, x train. And in this case, we want our missing values. So we want to use our imputer, right? So say from sklearn dot preprocessing import simple imputer, which we saw earlier today. Simple imputer, right? Oh, wait, I'm mixing up some old stuff. So if you don't remember, you just search for it, right? See, it used to be from pre-processing, but it's no longer. I'm thinking in the past. So this should be imputer. Okay, so this should work. Okay, and again, if I'm being good, I put it here. So simple imputer, and I call it, what am I calling it? Lot frontage. So they say lot, say imputer lot equals simple imputer. And then I'm gonna put strategy. This is where like I would actually investigate. So like I'll put a little something like to do investigate what makes sense here for lot frontage. Okay, so you want to make sure like that makes sense, but I'm just gonna breeze right through it, right? And so now I'm gonna do imputer lot dot fit transform, since I'm fitting it and then also transforming it. I'm gonna fit transform on x train dot, well, call it lot frontage. It was lot frontage, right? Hope so. I guess we should double check. Cool, missing values, lot frontage, good. I know Becky said it was, but I just wanted to make sure. All right, so let's see here. What did I do wrong here? Oh, I do this every time. Gotta do the, I think you just do reshape here. I don't remember if Pandas lets me do this. It probably doesn't. No, you don't. So I gotta go to numpy dot reshape. There you go. That should have worked. I'm not gonna worry about that warning. So just double check. If I do xtrain now, and I do xtrain.info, we should see there's no missing data. Perfect. Okay. So now we got our model. So let's actually train it some stuff, like actually perform some training. So let's say like my model. So let's say my simple model. Okay. And then we're gonna do, tell you what, from pipeline, what was it? Okay. After doing the imputer thing, it made me question if I'm the right thing. So we're gonna run this guy. And then we're gonna do say, okay, make pipeline. My simple model equals make pipeline. Okay, and this has to be in an array, or not an array, but list. So my mouse is dying. I just want to double check that I'm saying the right stuff. I'm wrong. Wow, Vector. Okay, see, you guys get to see me fumble too. All right, so I'm going to make a pipeline, and I'm going to use, the first thing is I'm going to fill missing data. yeah, fill missing data. And in this case, I would actually do something too, like one hot encode, skipping to do. Okay, so that's something like I technically skipped, right? But that would be one of the things. So I'm going to one hot encode, which we saw was my imputer lot. So imputer lot. And then I guess I would just actually put this here. So I really want to say like, oh, this is how you should train it, but I could put imputer lot like this. I'm going to skip the one hot encoding, and then I'm just going to do linear regression. So linear regression. And note that you don't have to put the, oh no, I'm wrong. You do have to put linear regression like that. Okay. So this is where also like, you know what, I'm going to try some interacting features too. So I'm going to go ahead and put interacting polynomial features. So I can actually do, I think I have to actually import that in there. What do I have? Polynomial features. sklearn pre-processing. So sklearn.preprocessing import polynomial features. And then polynomial features, what sounds like a good degree? I think 3 sounds pretty good. Yeah, sure, why not? Include bias equals true. Okay, so cool. I made my pipeline. This should in theory work. Make sure I have this guy run. I'm gonna put this up here so I don't forget. Delete this guy since I don't need it anymore. All right, so this should work. Oh, what did I do wrong? Linear regression. I'm gonna do linear regression is not defined. Oh, I have to import regression, huh? So from sklearn dot linear model import linear regression. Okay. All right, now I can run this guy. Cool. All right, so now I go my simple model, which is really simple. I'm going to do a dot fit, right? And my dot fit in this case is just going to be xtrain, which should be filtered already. So just remember that we did filter it, right? And I'm going to train it with y, and that should fit it. Oh, it's not called y, it's called y train. Okay, cool. So then I have this guy here. So now I can actually say, okay, let's make predictions. So make a prediction. So I'm going to do cross validation. Do I have enough time? Ooh, all right, getting close. From let's hear from sklearn dot model selection import cross validation score with cross validation, so CV, and I say cross score. Oops. Cross validation score, and then I think I have to just make sure you do the right thing. That's the model one first. Okay, so you do my simple model, you get x train, which should already be filtered, comma y train. Okay, and then this should be scores, and then let's just see scores dot mean and scores dot std. Okay, so all right, that's not too bad, I think. Okay, so we didn't do any scaling off to that. Like, okay, and then let's say at the final evaluation, so like this should technically be like right here. So like I had this out of order. Maybe I'll change it later on. But if I have this part, it would be evaluation. What I might finally do is like, okay, after training many models, simple model is the best. Okay, so it's kind of like what I'm seeing already. So I'm going to go ahead and say, okay, let me go ahead and make that how well it performs now. So I'm going to say like my model, which has already been trained at this point, or my simple model. So I'll call it like my model. So my model equals this. So that's like my final model in here. And it's like, okay, my model dot predict of, so I got to do some stuff real quick. So I have to do filter columns of the X test, right? And I'm just gonna call it X test filtered. Okay, and then I do X test filtered, call it Y hat. What went wrong? Sales price is not an index. Oh, okay. So that's because there is no sales price. I have to change some stuff on here. I do have to go, but this would basically, you would make sure you get those columns to keep. You filter in here. I tell you what, they can wait because I'm so close to getting you guys here. Okay, so I have to do some manual work. So this is where, like I said, like you have to make sure things are working correctly, but that's okay. So now I have my Y hat, and I spelled predict wrong somewhere. Oh, it's right here, isn't it? So, all right, I don't have time right now. Oh, it's because this right here, this ignore, it was in my test data, but wasn't in my actual. I have to make a default for this category, which is probably what's happening here. So something to keep in mind. I guess I should get rid of this neighborhood, but that's because I have to process it. I do have to head out though, but hopefully you guys see an idea here. You would then have this X test, and then assuming Y hat is your prediction, you would then, create CSV from Y hat. Okay, so if I have some time, I'll save this. I'll modify this, but I'm just saving it now so you guys can find it. But when I have some time, maybe even tomorrow, I'll edit this a little bit, or maybe today. Okay. So, all right, I do have to head out. Is there any last really burning questions or anything like that? No.
Thanks, Victor.
No problem. All right, I'll have this recording up hopefully sometime today. Okay. All right, take care, everyone. Have a good weekend if I don't see you tomorrow.
All right. Have a good weekend, guys.
You too.